Some say the universe will end in fire. Others in frost. But I say it'll end with cake. Infinite cake. I've discovered a paradox that is so powerful, so frosted, it defies logic, science, and portion control. Wait, where the heck am I? Each time I take half, the cake remains. Am I trapped in a delicious feedback loop? Or is just an excuse to eat more? Let's find out if it's possible to truly eat an entire cake.
This might be the dumbest thing I've ever done. And I once ate a sardine pancake. You eat half of a cake, and then half of that, and then half of that, and so on. Will you actually eat an entire cake though? This idea comes from an old mathematical problem called Zeno's paradox, which we'll talk about in more detail later. The basic premise is that if you go halfway each time, do you actually ever finish? First half. This looks delicious. I am excited for this. By the way, this is a Boston cream cake topped with strawberries.
This first half started out amazing. I was really hungry and I hadn't eaten cake in quite a while, so I was pretty excited for this. It wasn't long before I realized I had made a huge mistake.
I'm actually starting to get a little full already. Oh man.
But I powered through. I felt powerful. I felt a sugar rush. I felt like I don't want to eat cake anymore.
All right, now it's time for a half of a half, or a quarter. Trying to use a plate this time. You know what? Forget the plate. We're not using the plate.
By this point, the sugar rush was hitting really hard, and I was just rambling, slurred nonsense.
I gotta say though, doing this kind of helps at least with the mental component. If I had to eat the other half of the cake all at once, I don't think I'd be able to do it. But my brain is kind of tricked into thinking, oh, you're only going to eat just a little piece. Not a little piece, but a much smaller piece. It doesn't realize that I'm still going to have to eat all this. Trick you, brain.
I pushed through and finished that piece. 75% of that cake, done.
Time for another half. So we're down to an eighth. I think I'm gonna get to the point where I can't even do math in my head anymore. I'm so full. I don't know what the hell I'm saying now. Here we go.
I keep taking half. The pieces keep shrinking. But I am really, really full.
All right, time for a 16th.
Flavor fatigue hit hard, and it took a lot of willpower just to push on.
That cream flavor is getting me right now. (30nd). Down to 1/64th. Getting kind of hard to cut. Bon fucking appetit. So that means this is 1/128th. Oh, I don't want to take this bite. Okay, 256. I think, yeah. All right, next is 1/5/12th, I think. I don't know, my brain hardly works anymore.
It got to be difficult to keep track of the pieces as they got smaller and smaller.
4/10/24. Oh, my hand's shaking. Jesus. Get a clean fork. Can you see what I'm doing here? All right. Next is 1/100th. voiceover fill in for me.
1 over 2048. At this point, we're basically cutting crumbs.
Next half, and next half. All right, so the point is that we could continue on doing these halves till, we're busting out microscopes and cutting molecules and atoms. My stomach is done. Overdone.
Zeno's paradoxes are a series of philosophical arguments presented by the ancient Greek philosopher Zeno of Elea, circa 490 to 430 BC. The three most famous are Achilles and the tortoise, the dichotomy argument, and the arrow in flight. The paradoxes essentially ask the same question in different ways. How can one ever get from A to B if an infinite number of non-instantaneous events can be identified that need to precede the arrival at B? Let's pick the dichotomy argument as an example for discussion. The paradox states that which is in locomotion must arrive at the halfway stage before it arrives at the goal. So for example, suppose Atalanta wishes to walk to the end of the path. Before she can get there, she must get halfway there. Before she can get halfway there, she must get a quarter of the way there. Before traveling a quarter, she must travel an eighth. Before an eighth, a 16th, and so on.
Now, if you're still watching, and thank you if you are, you might be asking yourself, if we keep dividing in half, how do we ever start? Great question.
Also, you might be wondering, wait, you did the cake thing in reverse. Yes, that is correct, but that would make for a boring video.
Lots of popular literature presents the paradox starting at the half. The paradox still exists, you just lose the whole motion is an illusion thing, which we already know is not true anyways.
Using modern mathematics, Zeno's paradox does have a solution. Each step can be written out in fraction form, like so, where d is the total distance. At first glance, the answer might suggest d equals infinity, but good old calculus comes to the rescue. We can express the series as 2 to the n minus 1 over 2 to the n, which then can be simplified as 1 minus 1 over 2 to the n. Now, we can plug that simplified expression into our limit. What this says is that as n goes to infinity, the number of halves becomes 0, and so you are just left with d equals 1. Zeno's paradox, while is solvable, remains a pivotal reference point in the philosophical and mathematical exploration of reality, motion, and the infinite, influencing both ancient thought and modern scientific understanding.
This shirt right here, it's available. You can buy it. Link in the description. All right, well that was fun. I feel like I'm about on the verge of throwing up, so hopefully we'll make it through this.
What did we actually learn here today? Mathematically, it actually is possible to eat an entire cake thanks to Zeno's paradox.
Physically though, I am more than done. I feel like I'm going to throw up and pass out at the same time. Hopefully not, but that's what I feel like. Well, anyway, if you like this mathematical fun that we did on this video, then don't forget to like, subscribe, and stick around. We may do something more fun again. Thank you. I don't even know what I just said. Where am I? What am I doing? I'm getting a headache. Too much sugar.